Do you have this? I don't know what to do with it. Come, let me help you out. Get an ultrasonic sensor, get a breadboard, get an Arduino Nano. Get yourself some jumper wires, get a cable connector, and lastly, get yourself some PC. So I'm going to show you guys how to write the code to connect ultrasonic sensor with our Arduino Uno. Now, we have to understand the fundamentals. So how ultrasonic sensor works is that it sends sound pulse right across and then it gets the echo. So that's how it calculates the distance. So what we're going to do first now, we're going to set the pin mode to be able to get the pins of our sensor. So pin mode, we set this to the what output. Set it to the output and then set our pin 4 to the input. So we set our pin 4 to input now. So you have to set up our serial monitor so I should be able to see what the ultrasonic sensor is reading. So we begin at 9600. Alright, this is it. So now this pin 2 is our trig pin and pin 4 is our what? Is our echo pin. So this is the output, the one that sends pulse out. Alright, this is where we are going to trigger it. So it sends the pulse out, and then let's say, look at this my cursor now as ultrasonic sensor. It sends pulse out, so the pulse go to this point and then come back. Then the pin 4, so pin 2 sends pulse out, and it's coming back. Pin 4 reads it, then calculate the distance it went. The distance is sent it, and the one when it comes back. So with that, I can now divide by 2 and get the right distance. So what we are going to do now is that to set the pulse, we have to run a digital write command. So digital write now helps us send pin 2 low. So at first we'll set it to low. We are going to delay microsecond by 10. Delay microseconds by what? By 2. So we'll delay microseconds by 2. Then we'll set pin 2 high again. Let me just copy this here. So we'll set pin 2 high again. So we do high. Alright. Now we are sending the signal out, the pulse out here. Alright, then we'll delay again. Delay microsecond. So we'll delay microsecond by what? By 10. Alright. After we delay microsecond by 10, then we'll set pin to low again. So that is basically what we're going to do. We set it low. Alright, then we'll delay microseconds by 2. Then we'll set it high, send the pulse. Delay microsecond by 10, and then we'll set it low. And what we're going to do now, we're going to measure the distance. So what we are going to use here is long. Alright, this is a variable. In case you don't know what variables are, just put in the description. I will make a video just focusing on variables. Alright, so pause in. So what we are going to do here, we're going to take 4 and we're going to set it high, so we can actually get the duration it takes to go there. Then what we are going to do next now is we're going to calculate the distance in centimeter. Alright, in cm. So what we are going to do is we're going to take the duration, multiply it by what? By 0.0242, then we'll divide it by 2. So this will give us the correct distance. Now basically what we're going to do now is to set up our serial monitor to print out values. So the first value we're going to print out is duration. So this is simply formatting, nothing else. Alright, then below it we'll print out the main value. Alright, print, we'll call it duration, distance in cm, distance cm. Alright, I'm going to call it. Alright, then we're going to also print out, the cm value. So we call it print line. So to end the line there, so space cm. Alright, then we'll close this. I'm going to give it a delay of 100 milliseconds. Alright, so basically we are done with the code. So in case you're not following, so you can see the pin mode 1, and you can see the void setup 1. Right? So first of all, we'll send our pin out, pulse out to get the value. we divide it by 2 to get the duration, the distance, and then we'll print it out. So basically, so now let's check the code if the code is compiled successfully. So we can see that it's reading distance. So let me try to cheat it. Alright, you can see it. So you can see the distance is reading. Let me pick it up. Alright, you can see the distance is increasing. So if I bring my hand closer to it, it reduces. Alright, so you can see the distance. You can see it's reducing and increasing, So if I take it up now and then put my hand on it, so if I bring it out, you can see the distance is changing. So it works. Imagine a lot of things you can do with this. You can connect it to a car and then you can use it to do smart obstacle avoidance system. So